My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 73 of the 120 Days to Jamb Chemistry with Flash Isaac. In this episode, we shall be looking at the various homologous series, functional group, and structural formula. We shall be looking at about 12 homologous series. After this, I will write out the other homologous series. I am able to write out 8 now for space sake. And before I embark on my procedures, I need to say this very, very important. As at the time of recording this video, I do not have any WhatsApp group. I do not intend to have any WhatsApp group for now, for next year. In fact, for now, I don't really see myself having WhatsApp group. For 3 main reasons. One is that Jamb is not exam for fun or for play or for unserious people. There is no way you can prepare somebody for Jamb on WhatsApp, because how many videos are you going to send in the group? How many questions are you going to send in the group? Where you post one question, persons are arguing, people are posting different things. That is a very, very terrible user experience. Number 2 reason I am not a fan of WhatsApp groups is that for every group, up to 30-40% are not Jambites. They are there to cause confusion. They are there to defraud you, add you to various groups, tell you about runs which doesn't exist. And that does not make sense, which is a bad reputation. 3, when it comes to WhatsApp, there is a lot of fraud, and I am exposing your contact to so many persons that can scam you. Because once they join the group, they have the contact, they can do anything to you, any broadcast message. So I don't want to be a reason why you enter into any trouble. Since I don't have WhatsApp group, there are many persons that create various WhatsApp groups, call it Flashlearners or in my name. Some even upload my picture as their DP, their name Flash Isaac. Like, I don't know. So someone to be doing that, that person is obviously a fraudster for you to be using someone's identity. So if you're in any group where they say Flashlearners or Flash Isaac, they are scamming you. In most of the videos, you see my contact there. I told you my social handles are Flashlearners and Flash Isaac. You have all these things, yet someone adds you to a group, says it's Flashlearners, and you believe. Anyway, that is your problem. Alkanes, alkenes, alkynes, alkanans, alkanols, alkanols, alkanoic acids, esters, amides, amines, and ether are the various homologous series. Before now, we've been able to take a close look at alkanes. And I told you that the general formula for alkanes is CnH2n plus 2. And I told you that alkanes, they contain carbon with single bonds to other elements, like this. C to hydrogen. This is an alkane with 1 carbon. Alkane with 1 carbon is called methane. Methane. Then with 2 carbon, this will be H, 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 and H. C2H6. Then I further proceeded to say that these alkanes, they can lose 1 hydrogen to become CnH2n plus 1 instead of CnH2n plus 2. When an alkane loses 1 hydrogen, it becomes an alkyne. Let's say no hydrogen here, no hydrogen here. It becomes an alkyne. So If methane loses one hydrogen, it becomes methyl. You add I to the naming. This is ethane, an alkane with 2 carbon. Now this is methane losing 1 hydrogen. This is ethane losing 1 hydrogen. So this becomes methyl, this becomes ethyl. The reason for the loss of hydrogen is substitution reaction. In one of the episodes, we will see the various reactions of the various homologous series. Alkanes undergo substitution reaction, which means one of the elements can be replaced and another thing will be added. Alkanes cannot undergo addition reaction. Addition reaction is a reaction where bond, carbon to carbon bond, is broken and a new element is introduced. But since these guys already contain single bond throughout, it means they are saturated. So you cannot add a new element. This is what I'm trying to say. If you have carbon, another carbon, and you have 2 bonds here, this means this carbon has already carried 2 bonds, this carbon has already carried 2 bonds. So we will need only 2 hydrogen here, and here we will need only 2 hydrogen. With this structure is correct to maintain the tetravalency of carbon. Carbon needs to carry only 4 bonds maximum. So this carbon has 1, 2, 3, 4. These 2 bonds is also affecting this other carbon, which is 1, 2, 3, 4. Complete. And this is C2H4. In this type of compound, we say it is unsaturated because this to this is double bond. We can break this bond, this one bond, into 2 so that 1 comes here and 1 comes here. If we break this bond and introduce new elements, we are therefore carrying out addition reaction. So only unsaturated hydrocarbons can carry out addition reaction. The ones that are saturated cannot carry out addition reaction. And when it comes to combustion, all hydrocarbons will burn. Then you certainly get carbon dioxide and water as some of the products or a product of combustion of hydrocarbon. A situation where you have something like this, C, like this, you see carbon with triple bond to carbon. Now, this carbon has 3 bonds and this carbon has 3 bonds. This will just need only 1 to complete the tetravalency, and this will need only 1 to complete. So this is C2H2. This is triple carbon to carbon bond. This guy can break to give addition reaction. But look at where I'm trying to arrive at. Most or all the homologous series are derived from alkyne. And what is alkyne? Alkynes are alkenes losing 1 hydrogen. When this hydrogen is lost, we can put any other thing here to form a new functional group or to form a new series entirely. If this H that is being removed, that is being lost, is replaced by another functional group, another element, we formed a new homologous series. And we shall illustrate this in all the homologous series for you to know that I am going the right way. And like I told you before, arrow represents alkyne, which is alkane which has lost 1 hydrogen. If alkyne is an alkane which has lost 1 hydrogen, what if it gains the hydrogen back? It goes back to alkane. So alkane, the functional group is alkyne plus hydrogen, basically. And the structural formula for alkanes is CnH2n plus 2. And I think I talked about this. N represents the number of carbon. Like for an alkane with 2 carbons, it will have C2H, 2 times N, 2 times the number of carbons, 2 times 2, 4, plus 2, 6. So this is an alkane with 2 carbons. It will have 6 hydrogen. Alkanes are also referred to as paraffins. Alkenes are also referred to as olefins, and alkynes are also referred to as acetylene. Now for alkanes is ANES. For alkenes is ENES. The presence of double bond is what shows alkenes. Presence of double bond. Look at what we did here. Anytime you see double bond, you know that we are talking about alkenes. And since we have double bonds, the number of hydrogen in alkenes will be less than the number of hydrogen in alkenes, because some hydrogens have been removed and the bonds have closed. This is the general formula for alkenes. CnH2n. So, for an alkene with 2 carbon, C2, the number of hydrogen will be the number of carbon times 2, 2n, and that will be 4. So, H4. If it were an alkane, it will be C2H6. You see, 2 hydrogen less than in alkenes. Alkynes are YNE are organic compounds characterized by triple carbon to carbon bond. When you see a compound and you see at least one of the carbon has three bonds together, triple bond as you can see here, that is an alkyne. And the general formula for alkynes is CnH2n minus 2. That is, if you have 2 carbons, C2, the number of hydrogen will be 2n minus 2. 2 times 2, 4, minus 2, 2. So C2H2. Look at something. For alkenes, C2H6. Alkene with 2 carbons, we have 4 hydrogen. Alkyne with 2 carbons, we have 2 hydrogen. And alkane with 2 carbons, we have 6 hydrogen. How about for 3 carbons? For 3 carbons, we have 3, 2n plus 2. 3 times 2, 6 plus 2, 8. Here will be C3H8. Alkene, ENE, double bond, with 2 carbons, we have the number of hydrogen doubled. So for 3, it will have 2 times 3. 2 times 3 is 6. So C3H6. For alkyne with 3 carbon, the number of hydrogen will be 2 times 3, 6, minus 2, 4. So C3H4. So once they give you the number of carbon, just enter the formula, you will get the number of hydrogen and you'll be able to draw them out. Just know that for alkenes, there will be a place where you have double bond, and that is what reduces the number of hydrogen. For alkynes, you see a place where you have triple bonds, and that reduces the number of hydrogen as well. The next functional group is the alkanols. Alkanols are also referred to as alcohols. Alcohols or ogogoro. That is alkanols. And if this board is not extremely clear or crystal clear in your food, please stream this on YouTube and increase the resolution. You will spend more data, you will use data. But if you use up a lot of data, you spend money on data, you develop yourself and you blast your exam, will you not be happy? Yes, now you'll be proud of yourself. And if you don't use data and because you are saving money, you fail Jamb, the money you are saving will cost you 1 year, cost you another preparation, another reading, and you still buy data at that time to study. So what are we not talking about? Now, alkanols. The functional group of alkanol is OH. And how do we get alkanols? You see the structural formula, ROH. Here is an alkyl group. Once an OH gets attached to alkyl group, it becomes an alkanol. That is the functional group. And you see the structural formula, CnH2n plus 1. This is alkyl. The alkyl can be any number of carbon, any number of hydrogen, and OH must be attached to it. So if this longer alkyl, you also attach OH here, you formed alkanol or alcohol. If it's so long and at the end you have OH, and the OH can be here, let's say something like this. It can be here, while here is the H. Anyhow you look at it, this alkane loses 1 hydrogen here, and is replaced by OH. So the position should not confuse you. But so long you have OH together or OH like this is an alkanol. And the general formula is CnH2n+1. The functional group is OH. Ladies and gentlemen, with this, we come to the end of this episode. Because I've talked a lot, I've advised, and I've said much outside the series, so I don't want this series to be so long for you. Just meditate on what I've taught you, what you've learned. In the next episode, we'll continue from Alkanes until we get to the 12th Homologous series. Get the Flashlearners app, begin to practice and play with questions. To whom much is given should not run away with it. And subscribe to this channel if you've not done that already. See ya.